If you're given this relative motion problem where a ball is traveling 5 meters north and the wind is traveling 2 meters east, and I want you to find the velocity of the ball relative to the earth, could you solve it? If not, let's solve it together. Start by identifying our givens and unknowns. The ball is traveling 5 meters north. You can write this down as VB/A, and VB/A just represents the velocity of the ball relative to the air. It gives us the air 2 meters per second east, so we can write that down as VA/E, where that represents the velocity of the air relative to the earth. It wants us to find VB/E, which is the velocity of the ball relative to the earth. We can draw a diagram illustrating this. So we have the ball traveling north 5 meters per second, and then we have the wind traveling east 2 meters per second, and our resulting speed is going to be this vector here, VB/E. We have this angle theta between the north and the resultant vector. So we can know that this ball is going to appear that it's moving east due to the wind's velocity. I also just want to note that the wind is not pushing the ball east at all. It's not affecting the motion of the ball in this question. This effect on the ball is just due to relativity. Now we can apply our variables into the relative motion equation, and we get this expression here. Plug in our values for the variables, and we get this expression. We can't compute this directly. We must use the Pythagorean theorem because they're in different directions. So if we apply the Pythagorean theorem and plug in our values, we get this here, compute the expression, and get this for the final answer, 5.39 meters per second. But this is just the speed. We need the direction to find this velocity. We can update our diagram with the speed we just found. We need to find theta. So we can use trig. We use sine theta equals opposite of hypotenuse. Opposite is going to be VA/E because it's opposite to theta. And then the hypotenuse is going to be 5.39 meters per second because that's the largest side length. So if we plug that in, we get this expression here. Evaluate it, take the inverse to isolate for theta, and then we get approximately 22 degrees for the final answer. Therefore, the final velocity of the ball with respect to the earth is going to be 5.39 meters per second north, 22 degrees east. That's the direction because if we look at our diagram here, north is the ball traveling with respect to the air, and it says going north, and our angle is 22 degrees east of that.